is going to be kind of a fast video because we're just talking about transformations again. And we're not going to, go all the way back to learning about transformations like the first time we learned them. We are just going to apply them to a parent graph. And so we're going to be doing transformation of the rational function y equals 1 over x. Now, after this lesson, you should be able to graph the parent function, and then you should be able to transform that function and state excluded values. Okay, like a little bit of a note, excluded values are values that make the denominator 0, or values that you can't have in the domain. Can't have in the domain. All right. So what we're going to do is we are going to, for these problems, we're going to state the transformation of the following, and we're going to sketch it. Now, I'm going to be very clear here that I am not making perfect graphs. I'm just sketching it with key parts, okay? And then we're going to be stating the asymptotes and the excluded values. Okay, so let's first focus on this parent function. If you guys think about the parent function, you obviously cannot have a 0 on the bottom here. So you cannot have a 0 on the bottom there. So here is your asymptote that excludes x equals 0, okay? So we cannot have x equals 0, and we have an asymptote that's x equals 0. Well, it's also a rational function, right? And so the degree on the bottom is higher than the degree on the top. So that means that we're going to have another asymptote at y equals 0. Now, our y equals 0 asymptote, okay, all it's doing is guiding the end behavior. So our end behavior all the way to the left is going to get really close to that asymptote, and on the end behavior all the way to the right is going to get really close to the asymptote. So let's look at what our graph would look like. Let's just erase those two little incy-bincy things. Okay, I'm going to draw the graph right over here because I want you guys... I'm just going to copy this graph. Now, obviously you can see that it doesn't cross the asymptotes. And it has one key point for each little section. And so basically the key point is substituting a 1 in, I would get 1 over 1, which means I'd have a 1. And substituting a negative 1 in, I would get 1 over negative 1, which is going to be negative 1. Okay? So those are just two key points. And then so that kind of tells you how far away from the x-axis it is. And there's no stretch. This is the most basic one. Okay. So once we see that, we go back over to this and we can see that the difference between this parent function and our new function is that this one is 2 times the 1 over x, right? So this says we're going to be stretching, vertically stretching, a factor of 2. Okay, so that means when we stretch, our asymptotes do not change. So our asymptote will still be at 0, or x equals 0, and y equals 0. Okay, we still are not allowed to have a 0 in the denominator. So all of that is good. That's an excluded value. And normally we would go... When a 1 would go in, we'd have a 1 come out. But if we put a 1 in here, can you guys see how 2 over 1 is just going to give us a 2? Or 2 over negative 1 is going to give us a negative 2. So it's stretching twice as far from the x-axis. And it's still going to be guided towards the asymptotes, the end behaviors. Okay? Okay, so you can see how this one would be a stretch. So if I had 3 over x, instead of going to 1, 2, it would go to 1, 3. 4 over x, instead of going to 1, 3, it would go to 1, 4. Okay? So that's what the stretch is actually doing. It's moving away, right, from the x-axis. Okay. The next one that we see, we're going to see this is telling us to reflect the x-axis. okay? Because if I have f of x and I do the opposite of f of x, that is reflecting the x-axis. So what we're going to do is we still have the same asymptotes. But if you think about it, if we put a 1 in here, it would be the opposite of 1 over 1, which is going to be negative 1. That's why instead of being up here, it gets down here, right? Instead of going there, it's going to go down here. Okay, and then vice versa on the other side. If I put a negative 1 in, you guys would have the opposite of 1 over negative 1, which is just going to be a positive 1. And so that's where that came from. And so we have the graph down here now, and we have the graph up here now, because all of our outputs are opposite. So if the outputs, like in this section, the outputs are negative, so now the outputs are positive, right? In this section, the outputs were positive, so now the outputs are negative. So we're just doing the opposite of our function. So let's go through this again. So we know we still have, so we still have the asymptotes x equals 0 and y equals 0, right? We know that it's going to be reflection on the x-axis. Okay, so, and then we still we are not allowed to have an excluded value would be 0, right? Because we can't have 0 on the bottom. Okay, so the next two are really where we're getting the transformations. So when we look at this, this has x minus 3. And this division bar says that we're grouping this, which means it's kind of like if you were to look at it like, if you were to look at it like this, it would be 1 divided by x minus 3, right? So remember, when we have an x grouped with anything, we are going to do the opposite. So we're trying to figure out what would make that 0, because we're not allowed to have 0 on the bottom, right? So if we're not allowed to have 0 on the bottom, we need to know that x is not allowed to be 3. So that's an excluded value. Well, what we look at is this for the transformation, because the negative 3 is being grouped with the x, we know that it's going to be going to the right 3. So let's go just pick this up. I'm going to go pick this up really quick. I'm going to pick this up and move it down here for a minute. Let's see. Oh, I'm going to have to do it a couple times. Oh, shucks. Hold on. Let's go back. Let me see if I can move it. There we go. We're going to move it down here. Now, if we took this whole graph and we went to the right 3, 1, 2, 3, that's really all we're doing. So we haven't moved the y-intercept. So our y-intercept is still 0, but now our x-intercept, not y-intercept, the y-axis, the y-asymptote is still 0, but our x-asymptote is going to be 3, right? X equals 3. So horizontal would be, so this is the horizontal asymptote, and this is the vertical asymptote. So the vertical asymptote would be 3, and the horizontal asymptote would be 0 still. So you can see how all we did was move all of our points over 3. Now, if I was just graphing this and I didn't have the ability just to pick that up and drop it down, and I'm going to go ahead and I'm going to just move this over for a second. What would I do? I would just go, okay, well, if I'm going to the right, I'm not changing this asymptote at all, but I'm taking my vertical asymptote and I'm going to put it 3 to the right. So I'd move my asymptotes first, and then I know that if I haven't stretched it at all, related to the asymptote, I would be going to the right one and up one, and there's my point, okay? So we would be right here. And the same thing, but the other side, and we could draw it in. So you can see how I would get back to basically the same function, or the same graph, sorry. It's just in the new place. Okay, so this whole graph, the transformation was right 3. The vertical asymptote is now x equals 3. The horizontal asymptote is y equals 0. And we can actually, let's go ahead and put this on here too. So the vertical asymptote, horizontal asymptote, this is the vertical asymptote, and the horizontal asymptote. I wish I had more room, so that's what I'm going to do. Vertical asymptote, and then horizontal asymptote. Okay, cool. All right, so now let's go to number 4. This is our last one. Let's move this guy over. We're going to pick this. This is our parent graph. Let's go put this parent graph back. So this is what our parent graph looked like. And if you looked at our function, you could see this is our parent graph. And to the outputs, we're going to be adding 3. So this says we're going to go up 3. So the transformation is up 3. So if I took this function, if I took this graph, if I took this graph and I just went up 3, 1, 2, 3, you guys can actually see that I'm not changing my vertical asymptote at all, right? I'm still at x can't be equal to 0, right? That's still going to be my excluded value. And that's because the only thing in the denominator is x, and so that's the only thing that we cannot be. But when I say plus 3, now my horizontal asymptote isn't at 0 anymore because it moved up. So now it's at y equals 3. And again, if I was going to graph this, oh, you know what? Did I? Oh, you know what? You know what's funny is I can't really use this one because it's not the same size. So what we're going to do is we're going to clear this off like we did last time. Oops. We'll clear this off like we did last time. Okay. I'll just erase it. Okay. You can tell how technical savvy I am because, yeah, I'm just trying to do my best for you guys so you have something if you're absent. Okay, here we go. So let's say I started off and I'm like, okay, this only went up 3. So I'm going to take my horizontal asymptote and I'm going to take it up 3. And I still can't be 0 for my vertical asymptote. So I've set my vertical asymptote and my horizontal asymptote up. And then I have no stretch, right? So if I have no stretch, I'm still going to go from where they cross. I'm going to go over 1, up 1, and boom, there's my... that's going to be my point right there, okay? So I'm going to go over 1, up 1, and get that, and then over 1, down 1, and get that, and then just draw them in. Because there's no stretch, right? If there was a stretch of 2, I would have gone over 1 and up 2. If there was a stretch of 3, I would have went over 1 and up 3. And so that's all I'm really going to do. And the reason why I wasn't like a perfect picture is because this grate or this graph is not the same proportion as this graph, so it wasn't really working perfect, but it's okay because we are going to redraw it anyways. All right, I'm going to give you one more because this is kind of a short video, and this one is going to be without the marks, so hopefully it will be not too bad. Okay, so we're going to go 1, 2, 3, 4, 5, 6, boom, 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 boom. Boom, 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 boom. And we're going to kind of do it a little cray-cray here. So we're going to go y equals 2 over x minus 1 minus 3. Okay, so let's see what this says. This guy right here says we're going to stretch 2. Vertical stretch, right? And then this guy right here, x minus 1, is telling me we're going to go to the right 1. And then this guy right here is telling me we're going to go down 3. So what I'm going to do is I'm going to first go down 3. So if I normally am at 0, I'm going to go down 3. So my vertical asymptote is y equals 3. That's not my vertical asymptote, my horizontal asymptote. I don't know if I could make more mistakes here. Okay, now we had a vertical stretch, but we also went to the right 1. So if I took my whole graph to the right 1, then my vertical asymptote is now going to be at x equals 1. Okay, so far we've taken care of everything except for our stretch. So normally we would start at this like little intersection and we would go over 1, up 1, right? But because we have 2, we're going to be going over 1 and up 2. So our point will be right there. And so what I'm going to do is I'm going to, first I'm going to go back to my page. Okay, so where am I? Okay, here we go. So I'm going to erase this just so that it looks a little bit neater. And I'm going to go over 1 and up 2. And then back 1 and down 2. And then we're just going to get close to our asymptotes at our end behavior. And you can see how it's just getting a little bit further away from the asymptote. Okay, and that's how I would graph it. So hopefully that helps you guys. Okay, take care.